Hey everyone, I'm Samyak Agarkar and welcome to my YouTube channel, and this is machine learning vlog 2. So as you guys know, I'm learning machine learning, and about which I talked in the last video, the machine learning vlog 1. So if you haven't watched that video yet, please go and please do watch. It will just give you an overview of what is going to come next in these series. So it's been a week since then and I've made some developments in the studies. So I started with mathematics, the basic mathematics. I started with linear algebra. For linear algebra, I'm learning from MIT OpenCourseware, a linear algebra course taught by Gilbert Strang. It's very deep. It's very everything has been taught very well, and it gives you more understanding of the linear algebra. Though I have studied linear algebra in my elementary school and also in the engineering mathematics courses, but the way Gilbert Strang teaches the linear algebra is very different. It just opens your eyes to what are the other meanings to the linear algebra than just hey solving for x's and y's. So that's a great fun learning the linear algebra from that source. So I've just started. I haven't completed the course yet. There are some 20-30 videos, I'm not very sure, but I've just completed 3-4 of the beginning, and it's good. So today what I wanted to tell you is there are two things that I wanted to tell you. The one is the understanding of linear algebra. So all of us have we have solved for the equations like linear algebra. There is a line equation, so two line equations are given. You have to eliminate the x's and y's and then solve for x and y. Maybe you have done it for 3 variables or maybe even 4 variables, right? X, y, z and w. But other than just solving, there is some a picture of what linear algebra actually is. And the thing goes like those kind of variables we cannot have in a computer. Of course we can have those variables in the computer, but then managing the data, managing the space, managing the memory is a bit difficult, right? If you are just going to write for, if you are well aware of some coding examples, then if you are just writing for hey int x, int y, int z and stuff like that, then memory management is a bit of issue. But if you are going for an array, maybe a vector, then managing the memory, managing the resources of the computer are a bit easy. It becomes a bit easy. So there is something that I want to tell you, how we can implement the linear algebra part in vectors. So that is one thing that I want to tell you today, and the other thing that I want to tell you is what is the need of linear algebra in machine learning. So I'm going to give you just one simple example of how machine learning can be benefited from this linear algebra, right? So let's head into my desk on the board and I'll show you that. So we are here on the board and I'll just give you an example of what linear algebra is. You must have studied the linear algebra. So let's take two equations, 2x minus y equals 0, and let's say minus x plus 2y equals, let's say, 3, right? So these are the two equations, 1 and 2, and linear algebra is all about solving for x and y. So there has to be a value of x and a value for y which satisfy both these equations. And if you are well aware of what these equations are, these are the equations of lines. So this is about linear equation. Linear equation is all about solving for x and y's. So let's try to write it down in the coefficient matrix form, in the matrix form. So let's write down the coefficient. Coefficients are the constants which are multiplied with the variables, and we make a matrix out of it. So that's coefficient matrix. So the coefficient matrix will be 2 and minus 1 here, 2 and minus 1, and minus 1 and 2, minus 1 and 2. This matrix, let's call it matrix A. This is multiplied with a vector of variables which is x and y. So this is a vector, and let's call this vector as x, and here is a vector which gives the solution which is 0 and 3, right? So let's call this b. right? So what we got here is basically Ax equals b. So this is basically all about solving for linear equations. So Ax equals b is a linear equation in matrix matrix or vector form, right? And this is going to be beneficial for us to solve these equations in a computer, because hey, int x and int y, int x and int y is going to take up so much, because hey, int x and int y is going to take up so much space. It's a bit difficult to manage the data. So basically that is it. Let's write this vector, these equations down here, these matrices down here, just to save up space, because I'm going to delete to rub this all thing. X y equals 0 and 3. So we don't need all this now. So there are two ways we can solve for x and y's. So let's write down, let's see the first way, which is a row picture. TURE, yeah, row picture. So basically here we go row wise, right? If you know a vector 2 minus 1 minus 1 2, so we go row wise. Row wise is this way and then this way, right? So we are going to go row wise. Basically we have this plot of x and y. So let's say here is origin, this is 1 2 1 2 minus 1 minus 2 minus 1 minus 2, right? So and the two equations that we have are 2x minus y equals 0 and minus x plus 2y equals 3, right? So let's solve for the first equation, this equation. Now there is a little bit of hint for you. The line equation is always y equals to mx plus c. If c is 0, then origin is the solution, right? So here c is 0, so origin is the solution directly. You can check it here. 2 times 0 minus 0 equals of course 0. So origin is an solution for that. Let's solve for one more point so that we can plot a line. Let's say we take x equals 1. So if we take x equals 1, then we have 2 minus y equals 0 and y equals 2, right? So y equals 2, this x1 y2, this will be the point, right? And the line passing through these 2 points is actually this equation. So let's say equation 1, right? We don't need this. Let's solve for equation 2. So here c is not 0, so origin is not the solution. Let's try for x equals minus 1. So if x is minus 1, then 1 plus 2y equals 3, 2y equals 4, no 2, so y equals 1. So we have minus 1 comma 1, this point. Let's solve for one more point. X equals 1, so minus 1 plus 2y equals 3, 2y equals 4, so y equals 2. So 1 comma 2, the same point that we got in the first equation, and the line passing through these 2 points is equation 2, right? We don't need this for now. But so basically we saw that hey, there are 2 equations given and we solved for x and y. So this is the point, x equals to, let's write it down here so that it becomes easy for us to remember. X equals to 1 and y equals to 1, right? So hey, we knew this, right? So there are basically 2 lines which intersect at one point, and this is the point, this is the coordinate which solve for both the equations, and that is what we were trying to achieve, right? But this is all we know. Why so? Because this part is not easy to be stored in a computer. Of course you can do, but then managing the memory is a bit difficult. So what we are going to do is we are going to look at another picture which will be more helpful for us in computers to solve for these equations. So that is a column picture. Okay. So basically we first saw that, hey, there is a matrix given, we solve it row wise, so that was a row picture. Now we have a matrix given, we are going to solve it column wise, right? So we have a different coordinate system. Do we need a different coordinate system? I don't know, but let's see how does that go. Hey, here the first column is 2 minus 1 and minus 1 2. Turns out that what we can do is we can just multiply these columns with these vectors, individual values of these vectors, and thus we get the answer. So basically what I mean to say is, I'll just show that you afterwards. So the first column 2 minus 1 times x plus minus 1 2 times y equals 0 3. This is what I meant by column picture. This is what we want. So just remember this if you can, and we are going to solve for this on a separate coordinate system. And yes, in a separate coordinate system, maybe u and v, and that basically does not matter much, but hey, who cares? 1 2 3 minus 1 minus 2 1 2 1 minus 1 minus 2. We don't need this, maybe minus 3, I don't know. So the first column 2 minus 1, so we go 2 here and minus 1 down, so this is the point, right? Hey, the measurements are very bad, but hey, who cares? So this is my first column, let's call it C1. The first column is this one. The second column is minus 1 2, so minus 1 and 2, so this here is my second column C2. Okay, and we know that we want to reach to 0 3, so which is 0 and 3, this point, right? This is the point where we want to go. Hey, let's highlight the point. So what you can do here is we are going to add these two vectors so that we reach this point, right? So if you are well aware of how we can just add the two vectors, then we can just pick up this vector from here and place it here. So let's do that. What will happen is we will reach here, I guess, that is 1 times C2. This is, it will reach to 1 minus 1 1 comma 1. If you have some doubt, you can just cross check, and the other will go to this point directly, that is 2 comma 2 times C2, right? So yeah, this should form a straight line, but just because yeah, this should form a straight line, but my drawing is bad maybe. But the point is, what we did is 1 times C1 and 2 times C2, and we reached to the solution point. So that's 1 times C1 plus 2 times C2 equals solution, right? And it turns out x, if you remember what we did was C1 times x plus C2 times y equals b, right? And so x here is x equals to 1 and y equals 2, and this is the same answer, right? So of course this was inevitable that we are going to have the same answer whichever way we solve. But the point here is, these, if you look at these C1 and C2, these are vectors, and this is also a vector. So either you can represent them, these vectors, in terms of arrays in computer, or maybe you can have vectors directly. So in C language I am very sure of, there is a vector class where you can C++ you can directly store vectors. So that makes it very easy for memory management and solving equations. Basically matrices and vectors are much more easier to solve because they are closer to find in the memory and stuff like that. So this is one part that, hey, this also provides us a good we can say a overview of what is actually happening, right. So why linear equation, why we are learning linear equation for machine learning? So there is a problem called regression problem. We will take a simple problem, right, a regression problem. And how does it work? I don't know what is here. Maybe you have two variables x and y, and rather than calling them variables now, we can call them attributes or characteristics, because in real life we are not dealing with variables, we are actually dealing with attributes or characteristics of some real life objects, right, or maybe stuff like that. So maybe you are given some data set, already given data set, that hey, these are the data sets, these are the data points in your database, right. Now I want to know that hey, what is the y coordinate for this x equals to x naught, right. I want to know what is the y coordinate for x equals to x naught. Just go away. So what the computer will do, computers are very good in remembering the data, right. You just have to store them in storage space or in database, and that's it. Every time the computer wants to get the data, it will just access the data, and that's it. You have the perfect answers. Humans are not as great as computers in remembering the data, right. But so we want to know the y coordinate of this point. The computer will just go to this point and just find out the y coordinate, because it actually already knows the y coordinate equals y naught, right. Problem is when let's say I want to know what should be the y coordinate when x equals to x1, and this x1 there is no data in the database or in the storage space for the value for the value pair of x equals to x1, right. There is no data in the complete database. Now the computer is stuck. Now the computer does not know what should be the y coordinate. Here is where machine learning comes into the picture, right. We want the computer to somehow understand these given points, somehow take out some inference from these points and understand the data, so that whenever I say hey, what should be the y coordinate of x equals to x1, then it can come up with hey, this is the predicted value of y equals to y1 for x equals x1. I don't know. So maybe that is what we want to do with machine learning. Machine learning is all about the data is not known, but we want the computer to understand the given data set and then apply that education, that knowledge to other databases. So what we want is basically the computer to understand the points. Now what I can see from the data is hey, this is following a pattern. We can just estimate this data into a line, right. Estimation of data. We are estimating the points to be lying on a line, and this is exactly the regression problem. We are given a data set and we say hey, it passes through this line, or maybe some other equation that we want to have, and we can have in not just straight lines, but we can also have them in parabolic forms, or maybe exponential forms and stuff like that, and that doesn't matter much, but we are just considering a line equation here. So this is basically an equation of line equation, right. So what we want the computer to do is generate a line from these points, and then when I say that, hey, what is the value of y for x equals to x1, then it will just solve the line equation for x equals to x1, and then it will say that, hey, this should be the answer, right? And it can pretty much we can say that it pretty much gives us a very good estimation of y, and that is all about machine learning. So what we want is, hey, draw a line from these points. Now how these lines are drawn is a separate thing. There are many different algorithms for estimating a line from the given data points, and we are not going to go very deep into that, at least in this video. Maybe in the future I'll tell you these algorithms wherein we can find where we can estimate the data points into a line. But the gist of telling you all this is, hey, basically just solving for a linear equation can solve pretty much many problems in machine learning. So maybe you are given two fields and two attributes or two characteristics, x and y, and you have been given with some data set of, hey, these are the points which we know, and then we want to solve for, hey, what should be the value of y when x is given and the data set of which is not available in the data set. So there is a line equation that we estimate from all these given points, and then just the y coordinate of it at the given x is the answer. So this is a very simple example of how linear equations fit into machine learning, and that is what all I wanted to tell you, and that is why learning this linear equations, linear algebra, is so very important. So this is the current development made in the complete week this week, and that is what I wanted to. I did not think this video will be so long, but it turns out, hey, there is so much to tell you. There are so many different things that I am learning, and it's just a bit different experience for me to learn these things in a different way. This is not something, the linear equations is not something that, linear algebra is not something that I am learning for the first time. I have already done it, I have got marks in the exams also, but then learning in the perspective of machine learning, learning in the way it can help me in machine learning is a whole together different experience, and that is what is very exciting for me. So that's it. Maybe I'll post the next video in a week or so with the new developments that I make in the same topic, machine learning and linear algebra. I think linear algebra will take maybe 2 or 3 more weeks, because it is a vast topic. Some of the things like eigenvalues and eigenvectors and stuff like that, they are so very important in machine learning. I'll be telling you about those things also, and they are very important in machine learning. Eigenvectors and stuff are very important in the face recognition. So if you are aware of how face recognition, or maybe if you are aware of the technology of face recognition, that you take a picture and it just identifies who the person is, or at least identifies where in the face of a person lies in the complete picture. So there are some algorithms for that, Fisher face, eigenface and stuff like that, and basically the eigenface algorithm depends on eigenvectors, and that's why the linear algebra is so very important aspect of the complete machine learning. And then learning these vectors and matrices and also kind of linear algebra stuff is very important in neural networks also. So linear algebra is very important. So if you are following up with me, you can also do the same. You can just learn from the Gilbert Strang's videos on MIT OpenCourseware, linear algebra, the course from computer science section. You can find it on MIT OpenCourseware, or maybe you can also go for Coursera. On the Coursera there is an elementary machine learning course wherein they also start with the same linear algebra at the basics. So that is all. These are all the developments that I made in this last week. Hope you guys like this video, and see you in the next video. Till then, bye bye.